In this video, we will look at the chain rule. If y equals sine x, then the derivative will be cos x. And if y equals x squared plus 1, the derivative would be 2x. But what about y equal to sine of x squared plus 1? What is the derivative of this? We may suppose that the derivative would just be the derivative of the sine function and the derivative of the x squared plus 1 function. However, this is not the case. Let's look at an example of why this is not so. Suppose y equals 2x plus 1 squared. We can think of this as two functions composed together, similar to our last example. That is, the linear function 2x plus 1 and the square function. If we expand, we get y equals 4x squared plus 4x plus 1, giving us the derivative 8x plus 4. Now suppose we don't expand. Using our logic that we supposed previously, we might conclude that the derivative is just 2 times 2 plus 0 power 1, since the square function has derivative of bring the 2 down and reduce the 2 to a 1, and the derivative of the linear function 2x plus 1 is 2. However, we can see that this is wrong because the derivative should be 8x plus 4. So in other words, the derivative of a composed function is not the derivative of each function. Remember that y dash, or y derivative, can be written as dy dx. Now, we shall use this notation to help us find a very simple but useful rule known as the chain rule. If the derivative of y equals dy dx, we can say it is also equal to dy du times du dx, since we can imagine the du's cancelling, leaving us with dy dx. This is a very simple identity, but it's very useful in simplifying complicated derivative problems. Let's look at an example using this rule. What is the derivative of cos of log x? For these problems where we have a function of a function, that is, two functions composed together, we should let u equal the inside function, that is, let u equal to log x, and calculate its derivative. So we have du dx equals 1 over x. We return to the original and use this substitution to give us y equals cos u. And finding the derivative, we have dy du equals minus sine u. Now we multiply both sides by du dx. The du's on the left cancel, and on the right the u can be replaced by log x, and the du dx can be replaced by 1 over x. So we have the result that dy dx equals minus sine of log of x times 1 over x, or giving us a final answer of minus sine log x over x. I'd like you to try this one. What is the derivative of sine of e to the power of x? Pause the video and resume when you're ready to see the answer. Y equals sine of e to the power of x. Let u equal ex. Then we'll have du dx equals ex. Going back to the original and substituting in, we have y equals sine u. Doing the derivative and we get dy du equals cos u. Now we multiply both sides by du dx. On the left you can see that the du's cancel and leave us with dy dx. And on the right we can replace the u and the du dx. The u is ex and the du dx is ex also. So we have dy dx equals cos ex times ex, or in other words, a final answer of ex cos ex. Let's look at the procedure we're using, but without referring to any specific functions. Normally for these problems we'll have y equal to f, some function, the outside function, of some g, the inside function. What we do first is to let u equal gx and then calculate its derivative. Du dx equals g derivative of x. Then we return to the question and use our substitution of u. So we'll have f u. Now we shall calculate its derivative. Dy du equals f derivative u. And multiply both sides by du dx. You can see on the left the du's will cancel, and on the right we can replace the u and the du dx. I replace the du dx with g derivative, and then I'll replace the u with gx, since this is what u is. So we have the result that the derivative of two functions composed together, that is, the derivative of an outside function of an inside function, is the derivative of the outside function times the derivative of the inside function. Let's look at using this result directly in a problem without going through each individual step. What is the derivative of log of x squared plus 1? Log here is the outside function. X squared plus 1 is the inside function. The rule tells us to find a derivative, we do the derivative of the outside function. The derivative of log x is 1 over x, so the derivative of the outside function here would be 1 over x squared plus 1. Then we multiply by the derivative of the inside function. The derivative of x squared plus 1 is 2x. So we have a final answer of 2x over x squared plus 1. What is the derivative of sine of x squared plus x plus 1? Pause the video and try this one for me. When you're ready to see the answer, resume. Sine here is the outside function, and x squared plus x plus 1 is the inside function. The derivative of sine is cosine. So we have cos x squared plus x plus 1. Now we multiply by the derivative of the inside function. The derivative of x squared plus x plus 1 is 2x plus 1. So we have a final answer of 2x plus 1 cos x squared plus x plus 1. Here's another one I would like you to try. It's very long and you will need to use the product, quotient and chain rule for it. What is the derivative of sine of 2x times log of x squared plus 1 all over e to the power of x squared plus 1? Pause the video and try this one. Resume when you're ready to see the answer. This problem requires the quotient rule since it's of the form f over g. That rule is the derivative will be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. In the numerator we have to calculate the derivative of sine 2x log x squared plus 1. This requires the product rule. Also in the numerator we'll require to find the derivative of e to the power of x squared plus 1. This will need the chain rule. E power x squared plus 1. Now the derivative of this product. That will be the derivative of the first function, and then we keep the second function the same, plus the first function staying the same, and then the derivative of the second function. The rest will stay the same until we get to the end, which is e power x squared plus 1. This requires the chain rule. The outside function is e, the exponential function. Derivative of the exponential function is the exponential function, so this stays the same. Then we'll do the derivative of x squared plus 1, which is 2x, all over the bottom squared. So to finish, we now have to find the derivative of sine 2x and the derivative of log x squared plus 1. This will require the chain rule. Sine is the outside function and the derivative of sine is cos. 2x is the inside function and the derivative of this is 2. The rest stays the same until we get to log. The derivative of log x is 1 over x. So the derivative of log, the outside function, will be 1 over the argument. So in this case, log x squared plus 1 will have the derivative of 1 over x squared plus 1. Then we multiply by the derivative of the inside function. Derivative of x squared plus 1 is 2x. Then the rest of the numerator stays the same, all over the bottom squared. As you can see, all we required to use for this problem was the product rule, the chain rule, and the quotient rule. With these three rules and our basic derivative results from semester 1, we can calculate the derivative of almost any function once we take care in our calculations. That's it for the chain rule.